we wish to find the integral or antiderivative of this expression, which is a mess, it is possible to do it by expanding this with the distributive law, or for whatever you want to call it. Multiply this, we get a polynomial, and then we can take the antiderivative piece by piece. It's easier though if we call this entire expression w. And it's very often, I'm sorry, I want to call just this w.
Okay.
That is what I'm calling w. So what I really have here is going to be the integral of x to the fourth, w to the fourth dx. That isn't quite what we want. We want to have, here we have all x's, we ultimately want to get all w's. In order to get all w's, we have to first label this piece as w. It requires a certain amount of foresight and luck. Something that's in parentheses, that's a mess, is often a good thing to call your w or your u, whatever you call it. Next, we want to find dw dx. dw dx equals 10x to the fourth. That's what dw dx is. Now we solve this equation for dx. dw equals 10x to the fourth times dx. And remember, dw dx is really the derivative. They are not separate numbers like fractions. Based upon certain principles and limits that we did not discuss, it is possible to do this and get the right answer anyway, even though these are not really separate numbers. Solve for dx by dividing by 10x to the fourth. We get dw over 10x to the fourth, 10x to the fourth equals dx. Now I'm going to substitute in this equation what is dx? It's d over 10x to the fourth. So I now have this expression, x to the fourth times w to the fourth. So the dx, I have dw over 10x to the fourth. I'm perfectly lucky. This x to the fourth, this x to the fourth cancels. So all I have is as follows, w to the fourth dw over 10, which is the same as 1/10 integral of w to the fourth dw. This is easy to integrate because it's only w's. That was the reason. The first step was we have to label w, and then we find dw dx. We solve for dx, and we change the dx to something involving dw. If we're lucky, we did it the right way, it ends up that we only have w's left, no x's. So we have to first change a piece of this to w, then we change the dx accordingly, and hopefully the x's drop out. This equals to w to the fifth divided by 5 plus a constant, which is the same as w to the fifth over 50 plus a constant. And we change w back to this expression. I then get 2x to the fifth minus 4 to the fifth all over 50 plus a constant. That is the final answer.